Okay, good morning, everybody. Welcome to our November webinar. My name is Olivia Tomlinson. I'm an Inside Sales Associate here at PureAir. And today we're going to be looking at activated carbon and H₂S removal and why it's time to start looking elsewhere. So these are the topics that we're going to be covering today. For those attendees that have previously joined in for our PureAir webinar series, this will be a refresher on gas phase filtration. And for those that are new, I hope that this information is informative. So introduction to PureAir filtration. We are a small business located here in Atlanta, Georgia. We are woman-owned and operated since 2023. Ashley Jameson is our president. We were established over 20 years ago. We currently have more than 50 employees, and we sell to countries all over the world. And we're proud to say that we have sold to over 60 countries around the world. So some of the industries that we cover, we do toxic gas protection. It'll be like chlorine for water treatment plants, protecting electronics, biogas industry, indoor air quality, so hospitals, airports, things like that, as well as odor and emission control, so wastewater treatment plants and other manufacturing plants. So at PureAir, we specialize in gas phase filtration. So that's going to be focusing on the removal of molecules of gas from the air. That's different from solids or particles and mists. So those are a little bit bigger than what we tend to focus on in terms of particle size. Gases are usually about that 0.003 to 0.007 microns in terms of size, whereas mist is anywhere from 1 to 9 microns, and solid particles can be anywhere from 0.03 to 100 microns. So that just goes to show you the difference in the size of what we're trying to filter. Common gases that we remove, H₂S, of course, as well as sulfur dioxide, chlorine, ammonia, and other VOCs. Here we have a diagram that kind of shows how gases will move through our filtration medias located in a filtration system. So on the right, you'll have the inlet air coming in, and it'll come in contact with the first part of the media bed, and that's where the media will be spent first. So that represents this kind of gray area. And then we have this, as the air moves through the media bed, it'll, like I said, spin up this first set of media and slowly move into here where you'll have some media still available for adsorption. And then as well as you'll have the remaining media that hasn't been spent. So as the, like I said, as the air moves through and spins the media, eventually, and the media gets cleaned, clean air will come out on the other side, and eventually the media will have to be replaced. So in gas phase filtration, we have a couple different processes to help remove the gases in the air. So adsorption is going to be the adhesion of atoms, ions, or molecules from a gas, liquid, or dissolved solid onto a surface. So this is more of a physical process. And then we also have a chemisorption process, and that's going to be a chemical change between the gas and the surfaces. This results in a new substance, and it's an irreversible process. There's also a absorption, but that's mainly used for wet scrubbing, and so not gas phase filtration. So let's get into why activated carbon is not good for H₂S removal. Activated carbon has become the standard in terms of gas phase filtration for H₂S, but it's not necessarily the best for most applications. So activated carbon has a few limitations. One is that it's equilibrium driven. So once equilibrium is reached, the carbon will stop absorbing additional contaminants. This limits its capacity to remove pollutants effectively over time. This makes activated carbon less reliable in continuously high concentration environments with H₂S because it quickly reaches its saturation and can no longer absorb gases effectively. Activated carbon also has a humidity sensitivity, so it treats water vapor as a competing molecule. So in high humidity conditions, particularly wastewater treatment plants where H₂S is common, water molecules will occupy more pore spaces, leaving less room for H₂S and other targeted gases. This will lead to quicker saturation of the activated carbon and a significant drop in performance. When the carbon reaches moisture saturation, it's possible that it can even release some of the previously absorbed gases. And this is what makes that absorption process a reversible process. This will compromise air quality, of course, and requires more frequent media replacement. So it becomes more costly over time. Activated carbon also works well for organic molecules. So that's going to be any molecule that contains a carbon atom. For H₂S, obviously, that's just hydrogen and sulfur. So it's not going to perform as well. It works better for larger molecules as well. So that's going to be molecules that have a higher molecular weight. H₂S has a low molecular weight compared to other molecules. And so it's going to be struggling to compete with those larger molecules for space on the pores of the activated carbon. This goes into how the absorption process focuses. It mainly goes through a van der Waals force in terms of how the contaminants are absorbed onto the activated carbon. But this force, this bond, can occur between all molecules. In fact, the van der Waals force is typically has a stronger force with larger molecules. And again, H₂S is a smaller molecule, so this isn't ideal for H₂S removal. This also makes it extremely difficult to accurately test the media, and it results in breakthrough as the carbon becomes too saturated. So activated carbon is also not UL certifiable. This leads to some safety concerns as it can be hazardous when spent, and it can possibly lead to catching on fire. This is particular in chlorine applications. This reaction is a hazardous reaction, and so we have seen in other applications where it does catch on fire. Alternatively, PureAir, we recommend our engineered adsorbent media, and this is because it is safer. So it's UL certifiable. It allows for a broader range of contaminants, and we can also target for specific gases as well with these medias. It goes through a chemiabsorption process, which is an irreversible process, and it's more accurate. We're able to test the media life of the engineered carbon a little bit easier than of the engineered media a little bit easier than with regular activated carbon. So here at PureAir, we make and manufacture all of our adsorbent medias. So here we have some of the different products that we offer, and they can be combined and used in conjunction with any of them to create a preferred solution for any of our customers. So for a lot of our wastewater treatment plant applications, we'll use a combination of our CPS blend and our self-absorbed XL. For our pulp and paper mill customers, we usually recommend our pulp and paper blend, our PP blend. And so all of these are non-hazardous when spent, and again, go through a chemiabsorption process. So we're going to take a deep dive into our chemiabsorbent medias and what some of the processes that they go through, and see some of the applications. So again, with chemiabsorption is a chemical process. And so it's preferred for chemiabsorption. It works better with gases that have a lower boiling point. So as you can see here, chemiabsorption, as we go down the scale, is better at targeting some of these sulfur dioxide, formaldehyde, ammonia, and then that physical absorption is better for your organic molecules. For reference, H₂S has a boiling point of minus 60.3 degrees Celsius. So it's way down here, and that's why we recommend using an engineered carbon for H₂S removal. So our most recommended product for H₂S removal will be our Sulfazorb Excel. This is particular for like I said, wastewater treatment plant applications. Typically, we recommend that customers will have about 2/3 of Sulfazorb Excel in their system. And this product performs well not only in our systems, but also in competitor systems as well. So this has about a 66% removal of H₂S by weight. So this is definitely our, like I said, our higher end product for our H₂S removal. And this will lead to, like I said, fewer changeouts, saving customers money over time. Here we have our alumina that's impregnated with potassium permanganate. And so this also meets our it's also UL certifiable. This is our iconic purple media, as I've heard some customers call it. And we offer different impregnates, typically of 4%, 8%, and 12% impregnation on that activated alumina. And that just allows for a broader range of contaminants to be captured and removed. It has the capacity to remove H₂S as well as other gases. It also, when it's spent, you'll see that the potassium permanganate will go through a color change. So it'll go from this dark purple color to a brown, sometimes orange color when it's spent. So it's a good visual indication of when it is time to change out the system. Again, we're also able to perform our media analysis tests on this one very easily and get an accurate reading of how much media is actually still available for customers to use prior to needing to change out the media. So our blended media, we offer several different types, and it really just depends on the application and what gases that customers are looking to remove. But we like to use our blends because it allows for, like I said, a broad range of gas removal. Yeah, of course, these blends also meet the requirements for UL certification, and like all of our other medias, they're non-hazardous and easily removed when spent and disposed of when spent. So here we have our CPS and CPS 12 blends. We will use this a lot in conjunction with Sulfazorb Excel in our wastewater treatment plant applications for H₂S removal. We'll usually recommend that customers use about 1/3 of our CPS or CPS 12 blend in their wastewater treatment plant systems. The difference between our CPS and CPS 12 blend is just the potassium permanganate concentration. So the CPS 12 will have our PureAir 12 media in there, whereas the CPS blend will have our PureAir 8. So our self-absorbed FE-XL, and this is another one of our products that we use specifically for H₂S. It's great in systems where H₂S levels exceed 50 ppm. It has the ability to remove 45% of its weight. So this is a combination of our self-absorbed FE and our self-absorbed XL. So this is also great in our high humidity applications as well, because that iron oxide that's in the self-absorbed FE, that it prefers that humidity to help work with that reaction on it uses that humidity to help with the reaction between the iron oxide and the H₂S. Again, this is recommended simply because in wastewater treatment plant applications, that humidity, that water vapor molecules, they're going to be treated as a competing molecule. So whereas activated carbon will just get saturated with that with the water molecules, the self-absorbed FE is actually going to be able to use that to its benefit to help facilitate that chemical change between the H₂S and the media. One of our So one of the benefits of using our self-absorbed FE-XL is that it is a good alternative to the iron sponge application for H₂S removal. And this is because, as you can see in the video, they're doing a change out of the FE-XL from a system. And usually that iron sponge is going to get clumpy once it gets spent. So it's going to be hard to remove, which usually leads to longer change out times, which ends up costing more money just because people have to go in there and try to break up those clumps. Our FE-XL does not clump up. As you can see, it's easily coming out of the system, and that's when spent. So again, for high humidity concentration, for high humidity applications, for high H₂S concentrations, our FE-XL is a better choice in comparison to activated carbon or the iron sponge. And so this chart, if we go through here, you can see how which media blends are recommended, or which media types are recommended and why they're recommended. So you can see here the porosity. So of course, activated carbon has a lot of pores, and that's why it's a lot of times people use it for H₂S removal. But it's really not good for those those reduced sulfur compounds or even H₂S. If we go down here, you can see that the self-absorbed XL, of course, is a better choice just because it removes more in terms of H₂S. But you can also use it in conjunction with our blends to just get a more broad range capture of any odorous gases that you may encounter. A lot of times, you know, the activated carbon will be cheaper up front, just cost per cubic foot. But in terms of how often you're going to end up having to change out that system just because of how quickly it's spent, it's really not worth it in the long run. And of course, again, our medias are also UL certifiable, so they're safer for workers to handle in terms of changing out the systems, as well as just being in the system and going through those chemical changes. It's a safer process. Here we have one of our case studies. So a customer here at Chisholm Creek, this is a wastewater treatment plant application. And so they had extremely high levels of H₂S. And so because of that, we recommended using both our FEXL and our self-absorbed XL medias. Again, like I said, all of our medias can be used in conjunction with one another, depending on customer preferences and what they're experiencing. Any combination that we can put together, we will, to create a complete solution. And so we used our self-absorbed FEXL in the closer to the inlet of that system, just because again they had high humidity as well as high H₂S, so that using the FEXL in the beginning of the process allowed for some removal of that humid air as well as that H₂S, because it has a 45% removal capacity. And then we used the self-absorbed XL in the later stages of the odor control system. And that allows for, like I said, a complete removal of H₂S. So that the end result resulted in a 99.99% reduction in the odor emissions and allowed the system to operate effectively without frequent media replacements. So we ended up not only solving their odor control issue, but also saving the customer money in the long run. And so here we have we're going to introduce our lifeguard system. And so this is going to be our electronic monitoring of the media bed. And so this can be used on any H₂S system or chlorine removal system. We have applications on both. And it's a way for customers to be able to see and monitor when it's time for them to change out their media. So it'll give customers a reading in terms of the number of days they have until it's time for them to change out their system. So it allows customers to be proactive instead of reactive in terms of changing out that system. So for H₂S applications, sometimes customers won't replace their media until they start receiving odor complaints. And by then, you'll have to, go through all the processes that is required to procure new media and do the change out and things like that. Versus this, customers can go ahead and look and say, hey, in the next year coming up, we need to budget for our odor control system to be replaced, the media in there to be replaced. And so, like I said, this is a patented technology that we produce and can be used on chlorine systems and H₂S systems. It can also be used on any system that isn't ours as well. So we have applications where we've put it on competitor systems. And so ideally, this system, again, will just give a customer, like I said, live readings of that media bed and where that transition period is within their media system. Again, allows the customers to plan for maintenance proactively and avoids costly emergencies in terms of having to immediately replace media when they weren't planning on it, especially for chlorine systems, because our chlorine systems, typically chlorine systems are on standby. And so we will, typically our chlorine systems are on standby. So if a leak occurs and the customer is not aware of that, the lifeguard system will be able to tell the customer, hey, you actually experienced a leak, your media is now at this point, and so you may or may not be covered in the event of a full container leak. I'll now take some time to answer any questions you guys have.